Hello, everyone. This is Professor Francis. Today, we're going to go over some conversions, right? We're going to show you how to use conversion factors to convert from one unit to another or two units at a time. Excuse me. So we're using some sample data here. We have a table. In the table, we see the different colors. One of the rows are in purple. This is the measured data, right? We're going to do the calculations, which were made. Those are in the green rows here, right? Based on the measured data. So we're just going to do one sample calculations so you can kind of follow how the conversions work and how they convert from a set of units to another set of units. All right, so let's pick the Chevrolet all electric Volt, right? And it says here that it has 106 miles per gallon, right? So we want to convert that to, what's it say here in the orange, kilometers per liter, right? So how do we do that? Well, we're going to have to, since we're converting both units, miles per gallon, if you take a look down here, right, you see that MPG, miles per gallon, is actually miles over gallons, right? So we have 106 miles over 1 gallon. We want to end up with kilometers per liter, which is kilometers over liters. So we're going to have to multiply by a conversion factor to first convert the miles to kilometers, and then another conversion factor to convert the liters, the gallons to liters. Okay. So here we see the conversion factor that we use to go from miles to kilometers, right? 1 mile equals 1.6009 kilometers, right? We cannot use it, and this is an equivalence form. We cannot use the conversion factor in equivalence form. We have to write it in fractional form. That's fine, right? We have two numbers. We know we can write a fraction one over the other. So we have two options. We can either put 1 mile over 1.609 kilometers, or we can put the kilometers on top and say 1.609 kilometers over 1 mile. So how do we know which one to use? You see I have one circled. Well, if we're looking at what we're trying to do, we want to convert from miles to kilometers. So what do we want to, whatever we want to convert to goes on top. Since we want to end up with kilometers, kilometers goes on top, and that's why we picked this conversion factor. And you see that here on the second line. We use 1.609 kilometers over 1 mile. We multiply that by the given 106 miles per gallon, per 1 gallon, and we just follow the rules for multiplication of fractions, right? The other thing you should note is that in doing this, units will cancel out like numbers, right? So but only if we have a matching pair of units in the top and bottoms. Right? So they have to be matching in top and bottom only. So if we look here, we see we have miles in the top, which cancels out with the miles in the bottom. Right? Now we just follow the rules for multiplication of fractions. We multiply across, and we get 106 times 1.609 kilometers, right, on the top, which gives us 170.559 kilometers on the top, and 1 gallon times 1. Remember the miles are canceled out. So we end up with 170.559 kilometers on top and 1 gallon on the bottom. So we're halfway there. We got the kilometers on top. We converted from miles to kilometers. Now we have to convert from the gallons part. We want the liters on the bottom, right? And we have gallons right now. So we're going to have to convert that. So what do you think we're going to do? We're going to find the conversion factor between gallons and liters, which is right here, right? And then we're going to figure out when we write it out as a fraction, we're going to figure out where what goes on top, what goes on bottom. Well, remember what we want. We want this, right? We want the kilometers on top and the liters on the bottom. So if we want to end up with liters on the bottom, we have to have a conversion factor that has liters on the bottom. So we take this conversion factor, 1 gallon equals 3.785 liters, and that's right here. We put the liters on the bottom because we want to end up with liters on the bottom and the gallons on the top. So it's 1 gallon over 3.785 liters. We multiply that by what we got before here, which was the kilometers per gallon. Right? And again, we remember that the units will cancel out in top and bottom. So we have the gallons on the bottom cancel out with the gallons on the top, and we simply multiply across. So this time we have 170.559 times 1, which just gives us what we have here, 170.559. It's supposed to be a point there. 0.559, right? Do I have gallons here? I accidentally left a G in there. Sorry, guys. This G should not be there. it should be 0.559 kilometers on top. And then on the bottom, remember the gallons canceled out, we just have 3.785 liters. Now we have some numbers here. We have the units we want. Now we have kilometers per liter, but we have some numbers. So we have to see if we can simplify this by dividing the 170.559 by the 3.785. When we do that, we get 45.06 kilometers per liter over 1, which is the same thing as saying 45.06 kilometers, right, per liter. Right. So let's just check and see if that's the value that we have uh, in the kilometers per liter column for that car. And yes, it is, right? It's very close to, we said 45.06, right? This obviously is rounded. So we have kilometers per liter, 45, right? So now we're going to go from kilometers per liter, and we're going to calculate how many liters of gas it takes to travel 19,300 kilometers, right? So let's see what we need to do to figure that one out, right? Yes, it has something to do with conversion factors. Okay, so if we look here, we see that our units are kilometers per liter. We want to end up with how many liters? We want to end up with liters. So if we look at, let's look at the dimensions here, right? We have kilometers per liter. If we just flip this upside down and make it liters per kilometer, then when we multiply it by that 19,300 kilometers, the kilometers will cancel out. We'll end up with liters, which is what we want. So all we need to do is take the reciprocal of this fraction here, this fraction or conversion factor, 45.06 kilometers over 1 liter. We're going to flip that upside down. That's what we did over here. We get 1 liter over 45.06 kilometers. And then we simply multiply it by that distance that we're talking about, 19,300 kilometers. Remember that whenever we're multiplying two fractions, we have to make sure that all the numbers are written in fractional notation. So we just put a 1 under it, and then we multiply across, right? So what's going to happen? Remember, the units will cancel out if they're matching units on the top and the bottom, they'll cancel out. So the kilometers on the bottom here cancels out the kilometers on the top, right? And then we just multiply across following the rules of multiplication of fractions. So that's 1 liter times 19,300. It's going to give us 19,300 liters over, that is liters and not supposed to be kilometers there. Let me just clean that up a little bit. It's a little difficult to tell what that is. All right. So that is 1,300, I'm sorry, 19,300 liters over, we multiply across here, we have 45.06, right? Remember the kilometers cancel out? So 45.06 times 1, it just gives us 45.06, right? Now, so now we have liters, which is what we wanted. So all we need to do is simplify this number, and we divide the 19,300 by the 45.06, we get 428.32 liters. Okay. Right. And if we come up here and look, remember these numbers are rounded, but you do see for the number of liters for this vehicle, we have 428. All right, that's great. So now we know how many liters it takes that vehicle to travel 19,300 kilometers. All right, so the last thing we need to do is we need to convert this amount of gasoline. We want to see how much carbon dioxide emission is going to come from that. And luckily for us, it turns out there is a conversion factor that tells us that. It says for every liter of gasoline, right, there are going to be emitted 2.3 kilograms. That's what I said before. 2.3 kilograms of carbon dioxide. So all we have to do is multiply our liters by this conversion factor, right? And then we'll end up with how much kilograms of carbon dioxide is produced for burning that many liters of gasoline. And this is what we've done here below, right? So it's 2.3, the conversion factor is 2.3 kilograms over 1 liter times our 428 liters. Remember, we're multiplying fractions, so we have to put a 1 under the 428. And when we do that, right, we see that the liters on the top cancel out with the liters on the bottom. We're just going to end up with kilograms. We multiply the numbers out, so it's 2.3 kilograms times 428. That gives us, and on the top, that's what we get. And on the bottom, we get 1 times 1. So we end up with 98 approximately 984.4 kilograms of carbon dioxide is emitted when you burn that many liters, 428 liters of gasoline. Right. So if we go back up to the top here, we should see a number very close to that. Yes, it is. We calculated 984.4 kilograms, and that's because we rounded off to 428, right? And in the chart, it said 985 kilograms, which is close enough. All right, so there you see, guys, how we can use the conversion factors to calculate based on a measured unit other parameters uh, in whatever units we want to calculate. As long as we have the proper conversion factors, like you see here, that we've written out. Okay, so I hope this helps, guys. Right, and remember to like and subscribe if it does. Right, and I will see you in the next video. Have a good day.